All right, let's get into it. Today, we're not just talking about theory, we are building something. We're going to architect the storage for a web application on Google Cloud from the ground up. We'll make the kinds of critical decisions you'd face on a real project, one step at a time.
It's the first and maybe most important question you have to answer. Where does all your stuff actually go? Your storage choices, they're going to impact everything. Performance, how big you can scale, and of course, how much you pay. Get this right, and you're building on solid rock. Get it wrong? Well, that can lead to some pretty painful redesigns down the road.
So that's our mission for today. We're going to walk through a real-world scenario together. We'll figure out exactly what kind of data our app needs, and for each one, we'll pick the perfect tool from the Google Cloud Toolbox, and I'll explain the why behind every single choice we make. Okay, first things first. Before we can start picking services, we need a map, a blueprint of the problem. So let's break down exactly what kinds of data our application is going to need to handle. So our app really has 5 totally different kinds of data. First, you've got the basics, all the static web stuff. CSS files, JavaScript, images. Then there's the content our users give us, their photos and videos. At the heart of it all, we need a relational database to keep track of everything. And for our servers to work together, they need some shared configuration files. Finally, we need to think ahead. We need a place to dump all the data we'll want to analyze later on. This list right here, this is our roadmap. All right, with our roadmap in hand, we can get to the fun part, choosing our tools. We're going to tackle these 5 requirements one by one and find the absolute best GCP service for each job. Okay, challenge number 1, all those public-facing files. We need a home for our images, our JavaScript, all of it. And it has to be something that can serve files to users anywhere on the planet. And it can't fall over when suddenly a million people decide to upload their vacation photos. So the real difference here is how you get to the data. A persistent disk? Think of it like a super-fast USB hard drive that you plug into a single server. It's great for that one machine, but it's not meant to serve files directly to the internet. Cloud storage, on the other hand, is basically a piece of the internet itself. It's built to be a global file cabinet, accessible from anywhere with a web link. And the best part, it scales up to any size without you having to do a thing. And here's the key insight. Architecturally, we want to take this job away from our servers. By letting cloud storage handle all those static files and user uploads, our web servers are free to do what they do best, run our actual application logic. It's a clean separation of duties, and it's a total no-brainer for this use case. Next up, the database. This is the heart of our application, the brain of the operation. It's going to run on a compute engine virtual machine, and it needs a home that is just ridiculously fast and reliable for all those constant reads and writes. So we're back to our 2 main contenders, but now the tables have completely turned. See, a database doesn't want to talk to a web service. It needs a block device, something that feels just like a physical hard drive is screwed right into its motherboard. And that is exactly what persistent disk is. It provides the high IOPS, that's input-output operations per second, that a busy database absolutely craves. And this just proves the point, right? It's all about the right tool for the job. For serving web files, persistent disk was a terrible choice. But for running a high-performance database, it's our workhorse. It's the perfect choice to get the raw speed that we need. Okay, so we picked our workhorse, but hold on, we're not done yet. What happens if the entire data center zone that our database is sitting in has a problem? I mean, we can't lose data and we can't go offline, so we have to think about resilience. Now, this is where Google Cloud gives us a really powerful choice. A zonal disk is super fast, but it's all in one physical location, a single point of failure. A regional disk, though, automatically writes your data to 2 separate zones at the exact same time. It's a tiny bit slower, sure, but for a critical database, that is a very small price to pay for being able to survive an entire zone going down. For our app, we are absolutely choosing regional. All right, our next challenge is a classic scaling problem. As we get more popular, we're going to have more than one web server, maybe 10. They all need to access the exact same set of configuration files. We need a central, shared drive that all of them can connect to at the same time. Now, you might think, why not just use another persistent disk? Well, you can't. You can't have 10 different computers all trying to write to the same USB drive at once. It would just corrupt all the data. What we need is a true network file system, an NFS. And on GCP, that product is called File Store. It's a fully managed shared drive built for exactly this scenario. So here's the easy rule of thumb. If you hear the words shared file system or NFS, your mind should just immediately go to file store. It solves this one specific, very common problem perfectly. It lets all of our servers mount the same drive and share data without any issues. Okay, our last requirement is all about looking to the future. Our app is going to generate tons of data. Logs, user events, clicks, you name it. We need to store all of it somewhere that's super cheap, super safe, and ready for our data science team to plug into. And this problem brings us full circle, right back to object storage. Its whole design, built for massive amounts of unstructured data, combined with its incredibly low cost, makes it the perfect foundation for what we call a data lake. You just stream all your raw data in, and it can sit there safely and cheaply for years, just waiting to be analyzed. So yeah, we're choosing cloud storage. Again. But for a completely different reason. This time, we're not using it as a web server. We're using it as a massive, affordable data repository. It's the central hub that tools like BigQuery can connect to directly. It really is the center of Google's entire data ecosystem. So, after all of that, what have we actually built? Let's put all these pieces together on the board and take a look at our final system architecture. And there it is. See how every piece has its own distinct job? Cloud storage is handling all the public content and also collecting all the raw data. File store is managing the internal server configs, and that high-performance, super resilient regional persistent disk is powering our critical database. It's a really clean, purposeful design. Now, let's make this even more practical. We can actually boil down this whole thought process into a simple little cheat sheet you can use on your own projects. This is it. This is the cheat sheet. When you run into a new data problem, you can just come back to this logic. Are you serving web files? Think cloud storage. Need a fast disk for a database? Regional persistent disk. Need a shared drive for a bunch of servers? That's file store. Building a giant data lake. You're back to cloud storage. This framework makes these decisions so much simpler. Look, today we architected one very specific application, but your app, your project, it's gonna be unique. The real power here is applying this process, understanding the need, weighing the trade-offs, and then picking the absolute right tool for the job. So what problem are you gonna solve next?